All right, this is an interesting section. It's about a lot of the principles of addition and multiplication. And as always, it's good. The better you understand these things, the better the math language, the better you are at the language of math. But I find a lot of people like kind of intuitively know all of these things, so I'm not sure that the names of all of these principles are necessary. Um, but basic idea, so for both of these here, it's called the commutative property. It just means it doesn't matter the order which you add, and it doesn't matter the order which you multiply, you get the same result. And so, okay, so associative as well. So it also, for both of these two, it doesn't matter if you group them in a different way. The A and B are associating here, and then the B and the C are associating. So you would do the parentheses first, but it doesn't matter. You're going to get the same result. And the same for this string here. It doesn't matter if you did A and B first or B and C. You'll get the same thing. Okay, so let's go through some of this here. So we've talked about combining like terms. So the point they're trying to make is it doesn't matter the order which you add, and so you're allowed to add these up. It's real intuitive. It doesn't really matter. So they're doing the commutative property here, but the point is you can put people on the same team. You're allowed to reorder them. It doesn't change anything, and you get that. Okay, so the same here. I think the principle would just kind of confuse you. The point is like terms. So I've got, what do I have? 32R, they're on the same team, and 29S. So again, the idea is that the one you already know. We are just allowed to put these guys on the same team. So I've got 21N, take away 15N, what do I got? Plus 6N left. All right, so they're going to show you again here. It doesn't matter the way you associate them. You can pick and choose. Now, because it's only addition, normally if you see that grouping symbol, we would do this first. But because it's all addition, their point is that we could switch it around. And we could have done these guys first because it won't break anything. And the reason they do that is because putting these together with a like common denominator is much easier. And then we just get 1. And then you can make that 1 and 5/13 and as an improper fraction. So their point is it's just easier to do it that way. So again, this is grouped this way, so we'd think we'd have to do that. But it doesn't matter because it's all addition. We can do these guys first. And then we have 7/15 plus 8/8. And now this is 1. So I've got 7/15 plus 1, which is 1 and 7/15. Now to make it an improper fraction, 15 times 1 is 15 plus 7. We get 22. Put it back over the 15. All right, same again. We're going to group these guys instead because we're allowed because it's all addition. So I get 2/9 plus 12/12. So that's 2/9 plus 1, which we could do as this. And then we could turn it into an improper fraction. 9 times 1 is 9 plus 2. This is the same thing as 11/9. All right, the same is true for multiplication. It doesn't matter. Like, you would intuitively know this, but so we could do the 6 and the 3 first instead, and we'd get 18x. You could do the 8 and the 4 first. Oops, get 32x. You can do the 9 and the 7 first and make it negative 63y. Okay, now there's an identity property for both addition and multiplication. It means this. What can you add to a number to keep the same number? Well, it's 0, of course. And then in multiplication, you can keep the same number by multiplying anything by 1. Now, we have the idea of an inverse, which is this. In addition, an additive inverse is the opposite. And if you put additive inverses together, you get 0. Now, there's also something called a multiplicative inverse. It means that if you multiply them together, you get 1. Again, if you're going really far in mathematics, knowing these definitions would be really helpful. We use them in more advanced math too, but for now, they're pretty much, you already know them. So the additive inverse, what two numbers add together to get 0? Well, 5/8 and its opposite is negative 5/8. They are additive inverses. You add them together, you get 0. 0.6 and negative 0.6, you add those together, you get 0. Negative 8 and 8 are additive inverses. Negative 4/3 and 4/3. So just the opposite. That's all you got to do. Okay, so all it is the opposites of all of these. Because if you added it to its opposite, you'd get 0. Same here. I'm not going to do another one. So all the opposite signs, basically. Now the multiplicative inverse, it's called the reciprocal. What you're going to do is just turn the number upside down. So the multiplicative inverse of 9 is 1 over 9, because when you multiply those together, you're always going to get 1. So negative 1/9 reciprocal is negative 9. I would just turn it upside down. And so if you multiply negative 1/9 times negative 9, so the negatives would cancel, the 9s would cancel, you'd be left with 1. Now 0.9 is, we're going to change it to a fraction, it'd be 9/10, right? So its reciprocal would be 10 over 9, and those multiplied together would get 1. So the inverse of 4 is 1/4. The multiplicative inverse of negative 1/7 is negative 7. And I'm going to turn 0.3 into 3 over 10, so its reciprocal is 10 over 3. Okay, same thing here. This is A. B would be negative 5 over 4. C would be, so 6/10 is the same as 0.6. We're going to turn it upside down and get 10 over 6. Okay, another important principle that's real intuitive. If you multiply any number by 0, you get 0. Now, be careful on division. Okay, 0 divided by anything is 0, but we're not allowed to divide by 0. So division is this, like I've got the number 15, and I want to divide it among 3 people. That's what it means, so I'd give everybody 5. Well, if I had 15 and I wanted to divide it among 0 people, well, that doesn't make any sense. It's impossible. It'd be like 15 has to suddenly disappear. And so we give it a term called undefined. So 0 can be divided, but you cannot divide by 0. So the little slogan, under the line is undefined. And so the 0 under the line is undefined. And that's the reason why. Okay, so I'm multiplying by 0, so that's 0. I'm dividing 0 by something, so that's 0. But you cannot divide this last one by 0. That would be undefined. That breaks. I can't make negative 32 just disappear. So this is 0 because you're multiplying by 0. This is 0. Doesn't matter what you divide 0 by, it's still 0. And this one would be undefined. Okay, same thing. I'm not going to go through those. Identical. Okay, I was trying to see what they're doing here. Now, even though this is a bunch of algebra going on here down on the bottom, we're still dividing something, or dividing something into 0. So it's still just 0. It doesn't change anything. And here, I'm dividing by 0. Well, we're not allowed to do that. So it doesn't matter that we change the ideas and look more algebraic. It's still true. Anything divided, 0 but divided by anything is still 0. And the other way around is undefined, even if it starts to look like algebra. Okay, another principle they've got for us here is that it doesn't matter the order that we add. So these are opposites. So let's just get rid of them. And if I got rid of them because they were opposites, I would just be left with negative 73n. Okay, the order we add doesn't matter. These are opposites, so they're gone. So all I'd be left with is negative 48a. These are opposites. You're left with negative 92x. All right, it doesn't matter the order you multiply. So look what would happen if we switch this order around. Let's move him to the front. Now why? Well, they're reciprocals. So they would cancel down to 1, and you're left with 8 over 23. We could do the same here. So by putting them in a different order, they would all cancel down. These are reciprocals. So that's all gone. Just makes 1. So we've got 5 over 49. Okay, the same thing here. I'm not going to show. These would all cancel. If you moved it around, you'd be left with 11 over 25. Okay, now we're dividing, I think this got out of order a little bit, but we're dividing 0 by something. Well, that's fine. It's still 0. but you can't divide something by 0. That's undefined. Okay, same thing. This will be 0. That's undefined. Okay, now this looks complicated, but these are reciprocals. So they're going to cancel down to 1, and all that's going to be left is 6x plus 12. Okay, same here. The power of those being reciprocals is it just leaves 20y plus 50. We've got reciprocals, leaves 12z plus 16. All right, so I think all those ideas are pretty intuitive. I think you know them without the names, but the better you understand what it's talking about there, the more helpful it'll be as you move into higher math.